Welcome to SLS. Oh wait, that's copyrighted. Welcome to the Happy Experimentation Learning Place. Today, we are learning about how the value of a base in an exponential function affects the graph. This is an exponential function, where a is our base. The properties of the graph achieved with this function depend on this variable's value. Let's take a look at these four cases. Firstly, what happens when a is below 0? We'll be using a to the power of half for this example to explain. Using the inverse laws we have learned, we know that a to the power of half is equal to the square root of a. But what happens when a is a negative number, like -2 for example? That's right, it returns a math error, or an undefined value. This is because any negative number multiplied with itself gives a positive number. As such, getting a negative result from this is impossible using real numbers. Furthermore, the values of y alternate between positive and negative values for integer values of x, meaning the graph drawn is discontinuous. Next, let's take a look at when the value of a is above 0 but less than 1. The graph is a decreasing graph, where the y value decreases at a slower rate as the x value increases and cuts through the y-axis at a singular point. This is because the base, a, is a decimal, where an increase in power, x, would lead to a smaller y value. The x-axis is also an asymptote in this case, as the values of y will always be above 0, no matter what x value is used. Now, when a's value is exactly 1, the graph is a straight horizontal line. This is because any power with a base of 1 will equate to 1. Lastly, when the value of a is more than 1, the graph increases exponentially as it curves upwards with increasing steepness. The x-axis is an asymptote, as when a is more than 0, all values of y are more than 0, regardless of the values of x. Note that for the last 3 examples, the y-intercept will always be 1. This is because y-intercepts are found when x equals 0, and any positive value of a to the power of 0 will equal to 1. We really hope this has helped you. Here's a meme for your efforts.